So let's just start by some introduction. So my name is Bansagu. I'm a senior solutions engineer at Confluent, and my role really is to help customers in making their data pipelines more real time and also as a result delivering tangible business outcomes. I joined about 6 months ago, and I've kind of always been in the data space. So I've worked with data in kind of different guises in various roles. So I started off in the observability space, where I was looking at how companies can make sense out of event and alerting information for operational insurance. In the identity and access management space, working with companies around their digital identities and how effective they could be. And prior to joining Confluent, I was working in the enterprise service management space, looking at how companies can build frictionless autonomous processes, and how they use data to continuously improve those processes, as well as automating some decision points there. So Confluent was a real natural next step for me, and it helps me double down in the data space. So in the next 30 to 40 minutes, what I want to talk about is data in motion, why that's different, the value that it delivers to organizations. So we'll talk about some use cases, and a little bit about the underlying technology as well. It's not going to be a technical session, so we're not going to go into too much technical detail. So this should give you a great overview of the data in motion and event streaming space. If you do have any questions, please post them in the Q&A part of the Zoom. But I will be taking those those questions towards the end of the session. So I'll be covering those as well. So yeah, please ask away, and really excited to get started. So I guess before we start, right, let's talk about, giving you some context. So why are we here, right? And how did we get here, right? So we live in kind of amazing times of change. The world is very different to when I was a kid, and a lot of that is due to changes in technology, right? For example, like my son, he doesn't understand that this black device is a phone because it doesn't do any of the things that a phone does, right? It doesn't take photos or videos or play video games, or he can't contact his friends. I mean, we probably have to cut him a little bit of slack because he is 3, almost 3 actually. But you can see how the world has moved on, and as a result, that has implications for businesses as well, right? So if we look at how we use technology in the past, technology was a mere support function. It was in the back office somewhere. We innovated when we needed to grow, and it was good enough to run the business on yesterday's data. But because technology now is the business, we need to innovate. Otherwise, we're going to lose to competition. And as a result, we need real-time data infrastructure, right? So the major changes that is that companies don't only use more software as they used to use previously, but companies are increasingly becoming software. So if you think about Netflix and how they started their business, which was back in like 1997, if you remember, they used to mail out DVDs. You used to watch the DVD in your DVD player and then post that DVD back. Now Netflix, obviously a fully digital company, and really focused on their software platform. And if you look at the kind of the entrance in that space, like for example, I guess Disney, Amazon, and so many others, right? It's a very competitive space. So recently they've pivoted towards creating their own content, and distributing that on their platform. And just to give you a sense of scale here, Netflix has over 2,000 software engineers. So definitely heavily invested in a software first company, or becoming a software first company. And that transformation is happening in other places like banking, like transportation, speaking of taxis here, cars are also becoming digital. So no longer are they just hardware, they're tightly integrated hardware as well as software with millions of lines of code, right? If you look at the recent trends around software-defined vehicles, so vehicles, which have features and functions which are primarily enabled through software. And what that's doing for cars is transforming them from a product which is mainly hardware based to a software centric, electronic device on wheels effectively. Even manufacturing and the manufacturing of those vehicles has been impacted by software and using real-time data. So that transformation is happening everywhere, and there are certain companies, right, which are fortunate enough to build a stack, which is a new type of technology stack from scratch to take advantage of this. And there are other, more established companies which are seeing some of the, market share erode away through competition, and they've had to innovate to compete as well. So you'll recognize some of these names in transportation, but it's not just, transportation. It's happening in retail, it's happening in finance, it's pretty much happening everywhere, right? So I guess the logical question is, well, what enables, this transformation? Why is this happening? And we call out a couple of trends here. Obviously, there's a lot of things which are impacting this, but there's a couple of kind of key trends that we want to call out, right? Cloud is one of those, absolutely. And the cloud is kind of changing how we think about data centers, technical infrastructure, and every company is going to be moving to the cloud. Your company is likely moving to the cloud as well. If not, it might already be there. You've got AI and machine learning. So, machine learning changes how decisions are made. And this is increasingly happening autonomously. You've got mobile devices and ubiquitous connectivity, which is, impacting how users experience technology, and it's changing how, users interact with technology. So it's really kind of raising the bar. And, if I can rent a film, for example, with 2 clicks of my iPad, then I wouldn't tolerate a service which takes days to give me an answer. So again, we want things faster, we want things in real time. And data in motion is supporting that, right? So that's changing the way we work and we think with data, and it's underpinning a lot of the other trends that we see here as well, right? So when we we'll talk about event streaming and data in motion in a minute, but the underlying premise here is that real-time data beats slow data. And I want to take a second to kind of unpack that statement. So when we say slow data, what do we mean? We mean data at rest, right? So that's data sitting in databases, data lakes, data warehouses. And when we say beats, which is quite an emotive statement, really, what we mean is that as time goes on, the usefulness or the value of data to drive action will diminish over time, right? And this statement's true most of the time, where let's say, if you look at board level objectives, like I want to increase revenue, I want to reduce cost, I want to reduce risk, I want to increase my customer experience. All of these things need to be done now. You wouldn't wait for those things to be done, right? So, this slide is showing some of the kind of the use cases where real-time data is required and action on that data is important. Now, it's worthwhile mentioning that, data at rest, as we classify, is not a bad thing at all, right? You've got kind of business intelligence, which relies on reporting, or you've got batch processing, which is enabled through analytics, or even kind of, model training for machine learning algorithms, which you want to go ahead and analyze previous data. And that's all great. But the most added value comes from processing data in motion while it's relevant and in real time. So this ultimately has some implications for databases. And you might think, well, not so much, right? because we have, hundreds of databases now today. So, you have your SQL flavors, you have your NoSQL flavors, you have, graph databases, you have your document stores, you have your key value databases, in-memory databases, etc., right? So that part of our technical infrastructure is really well developed. But databases share a fundamental assumption, which is, data is passive when stored in a database. And let me try and kind of explain that by a couple of examples. So, if we think about data that sits in a database, it's really waiting for the user to do some work. So if I'm on a website, I click a button, we issue a query, it fetches information from the database. And it kind of is designed to react to what humans do. And that's how the software has been built around that, right? So it's really been designed for a very human-centric view of the world. So if we then look at an example to perhaps solidify some of that, when you think about getting a loan, so if I want to buy a house, for example, it's a slow manual process which requires signing a lot of pieces of paper, right? So for example, the bank will use software within that process, but essentially those software pieces are designed, on a persona basis and sometimes disconnected. So the mortgage broker is certainly doing some typing into the computer, but that might be separate from the rest of the business. And that has an impact on the outcome which we see, which is perhaps a longer waiting time, or delays in notifications because I don't know, what stage of the process my application's at. Eventually, you will get some kind of result to say it's been approved, it's been rejected, or there's a blocker here somewhere, right? So clearly, software is involved. It's not all manual, but it's really designed as a productivity aid for humans. And that's clearly not what the future looks like. It's really a lot more machine-based. And the end state is it's a fully automated process that will try and connect the different steps together. So humans will absolutely still be involved in that process, for example, from a key decision standpoint, maybe from an exception management standpoint. But the workflow from entering your application information kind of into the UI to a set of services inside the bank automatically talking to each other to eventually approve or deny that particular loan is going to be what the trajectory is for the future. So it's largely software carrying out a lot of those functions. And once we get that information, right, we can look at doing risk assessments, credit checks, and all of that can be done effectively in an automated fashion. And as a result, there's an implication on the user experience and what we see from a user outcome perspective. And that is the way, that we want to build a system, and it's going to have implications on what we do to design systems in the future. So if we kind of peel back the layers a little bit and think about, okay, well, if we think about the world that's using software, you could have a classic three-tier architecture. You've got your presentation layer, you've got the business logic layer, and you've got the data. The role of software is to display the information to the human or the user, and that's effectively the human driving the UI. So I click something, enter some information, and so on, right? Whereas the app service and the backend data are kind of passive. They're waiting for the user to do something and reacting to it. What we want to do is we want to move to a world where it's it's just machine to machine interaction. And we want to build architectures which support that, which are, just a lot more automated. So kind of another example of that is, for example, if I want to catch a taxi somewhere, right? And a lot of, I guess, if we again think about how that example works, we'll need a lot of information here, right? So, your current location, where you're at now, where you want to get to, how long it will take to reach the destination based on current traffic conditions. The pricing must be calculated. We need to match where the driver is, and if they're in the vicinity. You want to know, who your driver is, what their reputation is. And once you reach your destination, you want that taxi ride to be automatically paid. All of this, needs to be happening at the click of a button when you're using, maybe your mobile phone or whatever it is, and in real time. So there's a lot of things that are happening in the back end to provide you that seamless experience. And event streaming and data in motion is the technology that's making that possible. So what is that, right? What is event streaming? So event streaming, it is basically the connectivity issue within the organization, which is linking different parts of the business. And Apache Kafka is the underlying technology which makes that possible. So that's the de facto standard for event streaming. And application and services can plug into this central nervous system, if you will, or this data pipeline. And that can be used to communicate to each other, to each of the other systems, microservices, if you will, to get the outcome that's required, right? So we talked about event streaming a little bit and data in motion, and I want to try and break that down a little bit further, right? So what is an event? Maybe going back to kind of the fundamentals here. And an event is whatever happens to your business, is whatever the business really cares about. So for transportation, that could be a sensor measurement from a vehicle to analyze in real time, give maybe early warning signals to your customers about malfunctions or predictive maintenance. For banking, it could be financial transactions. For retail, it could be orders or shipments or something. And when we talk about a central nervous system, so if we take an example of, like, let's say Amazon, right? When you search and click for something, your activity is automatically being captured through Clickstream to analyze, what you're doing effectively and give you personalized recommendations. When you've clicked on an item that you like, like let's say like a book or a camera, you'll see up-to-date shipping estimates for your home address based on the stock or the inventory that Amazon carries. Once you've submitted the order, you'll get automatic updates and notifications on how your order is being processed and delivered to you, all of which is tracked and triggered through streams of events. And that seamlessness is effectively, why one of the reasons we go to Amazon, right? Because we know that they'll be able to process and deliver our order quicker than any of the other competitors, as well as being really kind of reliable, right? And then when we look at kind of the rise of event streaming, so how has this phenomenon come about, right? And the rise of event streaming can be traced back to 2010, when Apache Kafka was created by the future Confluent founders in Silicon Valley. It started to take shape in Silicon Valley, and then it moved on to the US West Coast, where in 2014, Confluent was created, and the goal was to turn Kafka into an enterprise-ready software stack, as well as a cloud offering. After which the adoption of Kafka really took off and accelerated. In 2020, there are tens of thousands of companies across the world in really all kinds of different use cases, and we'll talk about use cases in a second, which are adopting Kafka for event streaming. So when I talk to my friends or my family and they say, well, what do you do, and what does the technology do? I kind of say to them, well, you're going to be using Kafka whether you know it or not, right? So if you're using a smartphone, or you're shopping online, or you're making a payment, reading news online, or whatever, it's likely that's going to be powered by Kafka behind the scenes, right? So Kafka is effectively applied even in use cases that that seem a little bit or almost like an edge case, where for example you've got scientists and researchers in astrophysics who are looking at Kafka to help them coordinate globally distributed telescopes. So it's got a diverse set of use cases. Now, if we, talking about use cases, if we start looking at, well, what do organizations typically use Kafka for, right? And I want to paint a couple of examples of how would organizations, typically use Kafka. Here are some use cases here. So one of them is around Walmart. So Walmart, I'm sure you'll recognize the name. One of the kind of the largest retailers in the world, obviously. And just to give you a sense of scale here, Walmart has got 5,000 stores, 150 plus distribution centers, 53,000 trailers that they own, and they serve about 25 million customers per week. So it's a fairly large operation, as you probably expect. And today, Kafka is used for Walmart's real-time inventory systems, their fulfillment systems, fraud prevention, as well as security. And it's actually used quite pervasively across Walmart.com as well. So every single click is streamed in Kafka and made available to applications that need to consume it along with the data itself. And another use case which has recently come about because of COVID is Walmart's new service, which they've launched around the grocery pickup business. So what event streaming enables that service to do is when customers interact with the app, for example, all the behavior data is streamed into Confluent. When orders are placed, all the data goes into Confluent. When customers enter the store to pick up their groceries, that's actually an event which goes into Confluent, and kind of so on. So as you can see, Kafka is at the heart of what Walmart are doing in terms of their business transformation, right? Another example, which is probably worthwhile highlighting, is Capital One, which is a very different business from Walmart. And Capital One are on a journey to modernize the business of banking, right? So when we look at traditional banks, we know some of them need to compete with some of the upcoming competitors, of course, as you'll see in the market yourself. So what Capital One's doing is it sees event streaming as an essential way to run their business. So Confluent is integrated across all of the 4 major business lines that they have. And they're building an entire set of kind of modern capabilities around things like real-time fraud detection, via messaging, like text messaging, digital personal assistance to enhance the user experience. And they've also got a second look application which looks at duplicate charges in real time as well. And that effort for Capital One is so central that they've built a whole business unit around it. So as you can hopefully see from those 2 examples, that Capital One and Walmart have kind of event streaming central to their business and central to their business transformation in terms of what they're trying to do. So far, we've talked about kind of what got us here, what are some of the kind of the changes that have taken place, what is event streaming, what's data in motion, and a little bit about the use cases. And if you remember earlier, I mentioned a technology called Kafka, which is underpinning this. So what I want to do now is really look at, well, just give you an overview of, well, what is Kafka and what is that enabling, right? So let's talk about, a couple of key capabilities of Kafka, and, we can talk about what that kind of means and the implications it has. So Kafka, at the heart of it has 3 main capabilities. And one is to publish and subscribe to streams of events. The second is to store your event streams durably and reliably like a database. And the third is really to process and analyze your event streams in real time. And the kind of the past 6-7 months that I've been in Confluent, typically what I've seen is organizations start their journey off from a publish and subscribe capability set. But to think of Kafka as only, as a pub sub messaging system is a little bit like, thinking of a smartphone as something which only, takes calls, right? So it's a lot more richer than that. And what I want to do now is just try and dig into some of these areas and delve in and see if we can shed a bit more light into these areas. So the first thing is, that Kafka plays very nicely with existing systems. So it gets the data from those systems and makes them real time, so to speak, right? So it can do things like change data capture and bring in events from your databases and make them immediately available to other systems. So you can extract, for example, customer updates and transactions from a database into an event stream in Kafka. Then you can perform some real-time analysis. So, what you may want to do is things like data filtering. You may want to, filter out the PII data, for example, do aggregations, enrichment, joins, that kind of stuff in real time. And then you can feed that into, let's say, like an Elasticsearch for indexing, or a MongoDB, or a Snowflake, or anything which interacts with like a customer-facing application. So you can do all of that. And there are, hundreds of connectors that are available out of the box to databases, storage systems, cloud services, and many more. The second thing I want to talk about in terms of capability here is that there is durability within Kafka, right? So a lot of the data that you put into Kafka is, maybe business critical, right? Like, for example, financial payments, customer orders, car diagnostic information, etc., etc. And you may want to store that for a longer amount of time and not throw that away. And that might be because of, you want to keep that historical data. It might be legal implications, etc. So Kafka has a fault tolerant and scalable storage or persistent layer. So the example of the New York Times here is actually a really good one, because they use Kafka as a golden database, if you will, and they're storing a lot of their content from the 19th century to the modern day, effectively. So that's a lot of content with their storing, which makes Kafka mission critical to the New York Times, and it's actually a great example to give you a view of how you can have real-time data coexisting with historic data and get a real context of what's happened during that time, which is quite phenomenal. The third capability that I wanted to talk about at a high level is really the real-time processing. Around the data that you've got in Kafka, right? So here, for example, you've got real-time payments, and you can have output streams plus additional streams which you can join. You can join that with tables to be able to give you a real-time risk perspective on, is this customer really viable? Is this transaction real? Should we proceed with whatever we're trying to do? So if you think back to the earlier slide where I presented some of the real-time kind of use cases, this real-time processing will be absolutely valid for that. And probably kind of the final thing I wanted to talk about is really scale, right? So Kafka is one of those technologies which can truly scale with your business. So most companies will start their event streaming journey, with a small pilot project and, with little data volumes. But subsequently, you'll get more and more use cases as teams get confident, they understand the capabilities, and then they start exploring different use cases, sometimes in different business units. We often find that, right? And you'll have certain teams which are ahead of others, and you'll have a kind of a co-learning. And all the way to the Confluent, Kafka becoming a central part of their data journey, and becoming that kind of the central nervous system. And so if you look at the likes of kind of the Apples, the Netflix, the Microsofts, even Tencent in China, they're using Kafka at a very large scale, and it's all the same technology, right? So yeah, absolutely, it can scale for your business as well. So that probably leads me to say thank you. Kind of draws me to the end of the session. I hope you enjoyed the session. It was a kind of a real whirlwind tour around Kafka. And hopefully you learned a few things as well around event streaming and data in motion. Just to summarize what we talked about, why organizations are turning to event streaming as they mature their data pipelines and make them more real time, how companies use event streaming. So we talked about Walmart and Capital One, and also what the underlying technology is delivering, in terms of capabilities. So yeah, thanks very much for your attention, and I'm happy to take any questions. Let's see if there are any questions here. Oh, there's a question here. So thank you for the insightful presentation. What would you say about the security levels of data stored or taken for event streaming? Really good question, right? Because security is quite a key consideration, especially when you're using this for critical use cases, especially where customer data is held, for example. So there's a number of ways to perhaps talk about the security aspect, right? All the way from things like data isolation and making sure only the right people can access the right level of data, all the way to things like hosting data on the cloud. So we've got a capability called Confluent Cloud, which is a fully managed offering, and you look at how you put the checks and balances to make sure data is there's private connectivity options, for example. There's other things like bring your own key and making sure that the data is only visible to you. So I think it's obviously quite a broad question, but there are absolutely things which we have considered. So we've been running Kafka on the cloud as a managed service for quite a few years. And we've learned quite a few, lessons over those years. So yeah, I mean, either drop me a mail and I can give you more information, or go to confluent.io, and there's a number of things there. If you've got a follow-up question, by the way, please type it in and I can answer that. I hope that gives you some information of that. Take up or interest from government departments in the UK and elsewhere. So that's another question that's been asked. Yeah, so we do absolutely work with a lot of government organizations. Obviously, they have certain constraints, especially in the public sector. You see that quite often, and yeah, there's been quite a bit of take up. So if you look at some of the certifications Confluent's undergone as we've matured our journey, especially in the cloud and even on the Confluent platform side, that take up is absolutely increasing. So yeah, it's something that's of interest, and you know, I'd go back to kind of the, I guess the root cause of why some of that take up is happening is, you know, Kafka is a really powerful technology, right? And that goes in some way due to its natural adoption that's happened. But you know, there are challenges in managing some of that technology. So people want to move away from managing Kafka themselves and giving that, you know, that responsibility to people who've got the experience and knowledge, and that's why that take up is happening quite a bit. Yes, I will absolutely be able to share the slides. I think this session is being recorded actually, so as a result, yeah, we can send you a link afterwards, and yeah, you'll be able to see that. Does Kafka analyze, just another question here, does Kafka analyze event streams, or does that require an analytics connector? So there's a couple of things here perhaps to note, right? That Kafka, you know, we do have connectors as part of the Confluent ecosystem effectively, which allow us to connect to different sets of technologies. As I mentioned earlier, it could be databases, it could be other things, right? And within those connectors, you do have the capability to do light transformations. But there is a whole kind of subset within the ecosystem. So another capability called kind of KSQLDB and K-streams, which will do more the heavyweight transformations. And that would be also in real time. So as the data comes in, you know, we can do stateful transformations. So you can do that. Typically, I guess the use cases, so just to comment on that, could be quite different, right? So some people need to transform the data in real time, and sometimes what that means is they want to provide a materialized view somewhere, and Kafka's a great, you know, capability to do that through the KSQL database. But other times, you know, when you've got an ETL process, you may want to put that into more of a data lake, let's say, and then do historic transformation on that, and that may be siphoned off to other technologies. So there are various kind of options there. Just reading the questions here. There's a specific question here around how do you engage, in what position do you employ with, say, NHS IT teams in an ecosystem made up with hardware and other technology providers? I think it's a really good question, and I think that goes some way into probably a broader sense of how we work with, you know, an existing ecosystem. So as I kind of mentioned earlier, right, we're absolutely part of a data pipeline, effectively, if you will, right? That's one way of looking at it. And what we mean by that is that, you know, we would absolutely, you know, bring in data and put data somewhere else, maybe do some transformation in the middle. So we are actively developing connectors, you know, on a monthly basis or a weekly cadence, and delivering those to market to ensure that we can work with more and more software providers, and so you don't have to, you know, build any of those integrations yourself. So we've got a fairly rich ecosystem of about 120 different connectors, which we built. Some of them are fully managed, and others you have to manage yourself. But the IP effectively exists. So, you know, I can understand an organization, obviously, like the NHS is very broad. You know, I've had in my past some experiences of working there. So, you know, I can understand, you know, that you probably need a range of kind of connectivity. There'll be security implications that come with that. So yeah, we can absolutely help in that. I hope that was a good answer, maybe a general one. But yeah, again, feel free to drop me a line on the email address, and I can pick up anything else which, if you need clarification. Yeah, is there any more? Oh, could you explain the basic process of publisher and subscribe? Absolutely, yeah. So a PubSub is really, you know, let's say, for example, so if you look at Kafka, Kafka is an immutable event stream. At the center of it is effectively a immutable log, right? So you've got publishers, which could be microservices, let's say, which are publishing data into Kafka. And you've got you've got subscribers, which effectively are consumers, which are reading from Kafka. The beauty of Kafka is that the data within that log or that event stream or whatever you want to call it is persistent, right? So you can have different consumers reading from different places in that event stream. So if an application wants to just look at the real-time data coming in, then they can read from the end of the log. If you've got another application which wants to look at the historic context as well as marrying that up with the real-time data that's coming in, then they can start from earlier on in that log effectively. And what it does a great job of is decoupling the consumers from the producers, which has, you know, massive implications in terms of microservices design. Again, I hope that makes sense. Perhaps a little bit of a technical answer for this type of session. Yeah. I don't think we have any more questions. So yeah, if there's any more questions, yeah, please drop me a line, and the recording will be up on the web. I just want to thank you for attending. Thank you for all the questions, and yeah, hope you have a great day.